Hey everyone, I got some messages with questions about the tape diagrams for ratios and then tape diagrams for percents. So I'm going to do a couple problems to show you how you can use them to solve ratio and percent problems. So, problem number 1. For every $2 Angela saves, her brother Mark saves $5. If Mark saved $40, how much did Angela save? The first thing I'm going to do is create my tape diagram. I know that I can't make the shape that I want. That's what I know. Okay, so we've got $2 for Angela. So we'll put a square in. Didn't quite work the way I wanted. Okay, so there's $1 and $2 for Angela. And then Mark will save $5. So we do 1, 2, 3, 4, 5. So here's our tape diagram. Mark saved $40. So we know that all of this is equal to 40. And we've got 5 boxes that add up to 40. So each of those boxes has to be worth $8. Because 8 times 5 is 40. And in order for our ratio to be true, then these boxes also have to be $8. So if Mark saved $40, Angela saved 8 plus 18. I'm sorry, 8 plus 8, or $16. For our next problem, on the Superman roller coaster, there are 4 adults for every 7 children. If 48 adults rode yesterday, how many children rode? How many total people rode? So first, I'll make my tape diagram. With 4 adults. I'm going to do 4 rectangles first because 4 adults came first. Normally we would just draw a rectangle and divide it into pieces, but working on a Chromebook, it's easier just to do a bunch of rectangles like this. Also, in an ideal world, these would all line up. Okay, so we can see, pretend that that's complete, that there are 4 adults and 7 children. If 48 adults rode yesterday, how many children rode? So this top row is equal to 48. Pardon my annotating right over the problem. And we've got 4 boxes equal to 48. So we have to ask ourselves, what number times 4 is equal to 48? 12. So each of these boxes is worth 12 adults, which means each of the boxes on the children's part of the tape is worth 12. So then to find the number of children that rode, we would do 12 times 7 and get 84. Then to find the total number of people, we could just add 48 to that, and we would get 132. So we just added the number of children to the number of adults to find the total people. Next up, we'll do a percent problem. All right, there are 30 girls in 7th grade, 20% of them are not in band or chorus. How many girls are in band or chorus? So for this one, I would make a large rectangle. Okay, so here is our bar. This represents all of the girls in 7th grade. And that would be 30 girls. We also know that that's 100% of the girls because 100% is all. So it says 20% of them are not in band or chorus. Well, I know 20 goes into 100 5 times. So I can take my 100% and divide it into 5 equal pieces. Let's see if I can divide it equally. Yeah, close. Close enough. So each of these is 20%. And we know that because we divided it into 5 equal pieces. So 30 divided by 5 would be 6. So each of these pieces is 20% or 6 girls. So 20% of them are not in band or chorus. We can cross that out. Those kids are not in band or chorus. So we've got 4 pieces that are each worth 6 girls that are in band or chorus. Well, 6 times 4 is 24. So if 20% of them are not in band or chorus, there are 30 girls, 24 of them must be in band or chorus. We'll do one more percent problem. All right, Diego scored a 5 on 60% of his tests this year and a 4 on 40% of his tests this year. If he got a 5 on 9 tests, how many tests did he take? So when I first read this problem, I was like, whoa, that's a lot of numbers to keep track of. But then I realized that the 5 and the 4 are just scores. They don't really matter to the problem. So if I wanted to, I could replace those and say an A for a 5. And we'll call 4s a B. So that helps us keep track and not get bogged down in the numbers. Okay, on 60% of his tests and be on 40% of the tests. So we know that this is 100% of the tests he took. And I got to figure out what 60% of this bar would look like. But I know that if I divide 100 by 60, I'm not going to get a whole number as my quotient. So I need to figure out what size piece could I divide this into that could show me both 60% and 100%. And I know that 20 is a common factor of 60 and 100. So let's use 20. We know from the last problem that we'll have 5 equal pieces. Maybe I can divide it a little more evenly this time. Well, I get an E for effort. All right, so this is 20%. So 20, 40, 60. Here's what he got an A on. And then here, so he scored a 5 on those. And here's what he scored a 4, or what we're calling a B on. Now remember, that 5 and that 4, that doesn't matter for solving our percents because those are just the scores. We want to know how many tests there are. So he scored an A on 9 tests. So these 3 boxes are 9 tests. And if we've got 3 boxes all adding up to 9, each of those 3 boxes must be worth 3 tests. And if these boxes are worth 3, then these boxes must be worth 3. So how many tests did he take? 3 times 5, or 15. I hope that helped y'all. If you have any questions, please leave me a comment in Google Classroom and I'll be happy to help.